In waves, we'll see these three. First is phase difference, phase difference. Okay. Second is path difference, phase difference, path difference, and third one is time difference. Time difference. Right? Okay. So first one is phase difference. So what is phase difference? First we'll discuss here. First one is phase difference. Phase difference. Phase difference of a wave. Right? So I am taking a wave. So first we'll see how the which one wave is generated here. Right? Suppose if you take like this, so this is 90 degrees. Okay. This is 180 degrees. This is 270 and 360. This is zero position. So when it moves like this, so when it is moving like this, wave is in like this. Right? So this is 90 degrees. Right? When it is moving like this means it will move like this. This is 180. Okay. So it is moving, this is downward, no? This is downward. So downward means this one. This is 270. Okay, 270. Next is, if it moves like this means here, it will get like this, 360 degrees. After 360 again, move means then a wave will move like this, 360 plus 90 is 440. Next, here 440 plus 90 is 540 and so on. So you will get wave like this. So this is the generation of a wave. Right? Now, this phase difference actually we will define for two conditions. Taking single curve, okay, taking single curve and two curves. Taking single curve and two curves. Okay. Right? So this is the which one single curve. Right? So in this single curve we will define how to take the phase difference. Right? So actually this is the angles 90, 180, how the angles came 270, 360, 440 and 540 and so on. Right? I think these angles are clear for you now. Okay? Now we'll see this one. Right? Now a wave is like this. Okay, a wave is like this. This is y, this is t, time axis. Okay, so this is 90 degrees now. This one is 180. This 270, 360. Now I am defining this one. Which one? Phase difference for single curve. Phase difference for single curve. Single curve I am taking here. Okay. Single curve I am taking and defining the phase difference. Right. Suppose this is the 0. Right. Now I am taking a point here. Suppose A point. Right. So when you are taking a point, this one, the curve is here. This is 90 degrees. Right. So when you are which one defining if you want to define the phase of the curve at A means that is 90 minus 0 is 90. Your phase difference is 90. 90 minus 0. So if you want a phase at A means, so this will be the starting point. So this will not be there. So how much phase here? 90 degrees. Right? Now suppose if I take a point B here, what is the phase difference at B means So this B is again with respect to 2 points A and O. So when you are defining with respect to which one, B with respect to A or B with respect to 0, because you can define the phase difference of B with respect to A with respect to O, because B is after this one O and A, right? Right. Now B with respect to A means what is B phase 180? Here this 90. So 180 minus 90 is 90. So B with respect to A phase difference is 90, right? So what is the meaning of this one is, so your curve is like this. So your curve is starting point is this one. So it is out of phase. You are defining with A, no? So it is out of phase of 90 degrees. If this is not there, right? So if you want to define with 0 means 180 minus 0 is 180. Means if this is not there, means if this curve is out of phase of 180 degrees. So that is the which one procedure of defining a phase difference out of phase, right? Suppose if you take a point C here, so if point C means this is not there, suppose. So your curve is out of phase of 360 degrees with respect to O. Followed. So that is the procedure to define the phase difference. So it is with how much degree it is of out of phase. So you have to define the phase difference with respect to points here. B with respect to A, how much phase 180 minus 90, or C with respect to B 360 minus 80, C with respect to A. So this angle minus this angle, or C with respect to 0, 360 minus 0, and so on. So if you take a single curve, so this is the procedure you can follow to find the phase difference, right? Right. Now, if you take two curves here, so you already told that you can define the phase difference for single curve or for two curves here, right? Suppose this is the one curve, this is y of t, this is time axis, right? Now I am taking two curves here, right? So this is one curve, okay? So this is one curve. So second curve, suppose it starts here. So second curve is starting at here, right? It is going like this. Okay. Means this first curve is starting at 0. This second curve is starting at pi by 2. Right? So your phase difference is pi by 2. And the symbol for phase difference, so the symbol for phase difference in the physics we will follow the symbol phi. Phi is known as phase difference. So what is phi here? Pi by 2, right? Okay. Suppose if the curve is starting like this, so this is the curve here. I am taking for two curves, no? This y of t, this is t, okay. So this is one curve, okay. And suppose your second curve is starting here. Your second curve is starting at this point. So at this point, suppose it is starting at this point, right? So your curve will be like this, suppose. So your curve is starting at here, not at here. So this 90, this is which one? 180 degrees. So at 180 degrees, suppose the curve is starting, no? After 180 the curve is starting means this is 90 and 180. So your phase difference is 180 degrees. So where the second curve starts, so that is the phase difference, right? Suppose if the two curves are like this, so this first curve, right? And your second curve is like this. The second curve is on this curve only. So what is the phase difference here? What is the phase difference? 0. Because both curves are starting here and they are intersecting, so your phase difference is 0 degree. right? So this is the actual which one procedure to find the phase difference for a single curve and for a two curves here, right? So for a single curve means like this. Suppose this is curve like this. Okay, 0, 90, 180, 270, 360. Sorry, this is 270 and 360. So if the curve is not like this, means you have to show with dotted lines. Curve is, so this curve is out of phase of 90 degree. Okay, right. Now see this one. Now see this curve here. See this curve. I am writing the equation here for phase difference. Okay. So this is time axis. This is y.r.t. Okay. Okay. Now this is 0. This is pi by 2. 90 no. This is pi. Okay. And this one is 2 pi. 360 degrees. So in terms of angle, these are the which one phase or angles on the curve, right? So without angles means what is this value? What is this value? This value is lambda, wavelength, right? Complete which one cycle or which one crust to crust is a wavelength. This one is a wavelength, and this one complete cycle is a which one wavelength here, right? Now this lambda is equivalent to 2 pi, because with respect to angles this is 2 pi. With respect to wavelength this is lambda. So for lambda it is 2 pi. For a wavelength lambda, what is the which one total angle here? 2 pi, right? Now what I will do is I will because this is a standard, no, for a which one wavelength lambda 2 pi you are getting. So here if you want we have to compare with wavelength and pi, you can take, because this is lambda by 2. For lambda by 2 it is pi. For lambda by 4 it is pi by 2. So for the standard angles you can write down in terms of lambda. So for lambda 2 pi. Now if I take 2 points here like this, A and B, right? I am taking 2 points here, A and B. This is delta x, suppose. This is delta x. Okay. This is delta x. So for delta x, what is the phase? For lambda, the phase is 2 pi, phase angle, phase difference. So for delta x, because these are not standard points, no, A and B are not standard points here. Whereas this is standard point, this is a crust here, this is standard point, these angles are all standard points. You can write down in terms of lambda, this phase difference. But here, if I take 2 points here like this, A and B, what is the phase difference here? So for lambda you got 2 pi. I want for delta x how much? How much phase difference? So this is, if you cross multiply this one, 5 into lambda, okay, 5 into lambda equal to 2 pi into delta x, okay, 2 pi into delta x, okay. So what is phi here? Phi is 2 pi by lambda into delta x. Phi is 2 pi by lambda into delta x. So this is actual formula for a phase difference, right? So for a phase difference, what is the formula? Phi equal to 2 pi by lambda into delta x. So this is a phase difference. So this is phase difference. This is phase difference. Okay. And what is delta x here? Delta x is known as path difference. Because we took A and B now. So A and B means what is the path difference there? Delta x. Okay. So already we took like this, no? So this is the curve here, right? So I am taking this one A, this is B. So this much of path difference is there between A and B. So that is delta x. So delta x is known as path difference. Okay. And phase difference is phi. Okay. Right. Now point A is close to this which one starting point of the curve. Point B is away from this one. No. When so this A is the point. A is leading point. You can say A is leading point. Right. Okay. Now we got the formula for phase difference. So phase difference with respect to path difference. Phi equal to 2 pi by lambda into delta x. Okay. Now I will take two curves here like this, right? So this is y of t, this is time t. Okay. Here I am taking two curves like this, right? This is one curve, okay, and another curve I am taking like this. Okay. So these are the two curves, or you can take like this also. First curve is like this. Okay. And second curve you can take like this. Okay. Now here I will take the which one between these two curves. I am taking a time difference here, delta t, because this curve is traveling like this curve is traveling like this, so there is some time difference is there. So that I am writing here, right? And one more thing, also we know that in terms of lambda, so this is actual which one complete wave. Complete wave means one thrust and one trough is known as complete wave. This maximum point of the curve is known as crest, and maximum point below this curve is known as trough here. So if a curve contains one thrust and one trough, and starting and ending points are on the mean position. This line is known mean position. As the particles are at rest, this is known as mean position, whereas the particles are vibrating on the curve, because particles vibrate, so that's why you are getting a curve, whereas the particles of the air are on this line are at rest position. So this line is known as mean position. So your starting and ending points are mean position. If it contains one crust and one trough, this is known as one complete wave or one complete cycle, right? So for one complete cycle, so this is known as time period t, or you can take wavelength lambda also. So to define that which one path difference, we took lambda there, but here we are defining time difference. So that's why I want time. So this is known as t. Capital time means time period. So or you can take this as lambda, but here I am not taking lambda because I am going for time difference here, right? So for t, actually you know the angles. No, this is 0, this is 90, this is 180, this is 270, this is 360 is 2 pi. Okay. So for t, what is the phase difference? 2 pi, right? So but here I require for delta t. Delta t, what is the time difference? So for time period it is 2 pi, which one phase difference. For delta t, how much? So for delta t, what is 5? If you cross multiply this one, 5 into t equal to 2 pi into delta t. 2 pi into delta t. Okay. So what is phase difference? 2 pi by t into delta t. So this is the which one formula for time difference, right? So your time difference formula is 5 equal to, right? You got 5 equal to how much value you got? 2 pi by t into delta t. So this formula you got. So here, what is phi? Phi is phase difference. Phi is phase difference. Okay. And delta is time difference. Time difference. Okay. Then now we got two formulas here: path difference and path difference with phase difference with respect to path difference, phase difference with respect to time difference. So the two formulas I will write here. Right. So what is the first formula? Phi equal to 2 pi by lambda into delta x. So this is the first formula, right? Phi equal to 2 pi by lambda and delta x. What is second formula? We got same phase difference equal to 2 pi by t into delta t. This is second. So both are phase difference only, but this formula is phase difference with respect to path difference. This one phase difference with respect to time difference, right? Okay. Now you know what is this path difference and time difference. Suppose if you take a wave like this, you are taking a point here. Suppose you are taking a point here, right, or taking a point anywhere. Suppose this is P1, this is P2. P1 values are, suppose if you take P1 values are x1 T1. P1 values are x1 T1. P2 values are x2 T2. So what is the path difference? Because your point P1 is at x1, P2 is at x2. So what is path difference? x2 minus x1 is path difference. What is time difference? T2 minus T1 is time difference, right? Now what I do is I will divide these 1 and 2 equations. I will divide like this, dividing this 1 and 2. So your 5 will get cancelled here, 2 pi will get cancelled here, right? And what is, you can write down the relation between delta x and delta t here. So what is delta x here? So this delta x, so you can take this on the right hand side. If you take this on right hand side, your delta x will be, this will be t by lambda, right? T by lambda, so not delta x, this will be t by lambda delta t, no? Delta t into delta x. We'll get this relation. So now we got three formulas here, right? What is this? Is the first formula, phi equal to 2 pi by lambda delta x. Second formula is phi equal to 2 pi by t delta t. Third is delta t equal to t by lambda delta x. So these three formulas are there for path difference, phase difference, and your time difference. So first formula is phase difference is equal to 2 pi by lambda into delta x. This is the first formula. Phase difference with respect to path difference. Next is phase difference with respect to time difference. So what is that formula? 2 pi by t into delta t. So this is the second formula. This formula is which one? Phase difference with respect to time difference, right? So what is third formula? By dividing these two, we got delta t equal to, right? Delta t equal to t by lambda into delta x. So phase difference with path difference, phase difference with respect to time difference with respect to path difference. So these are the relations here for path, phase and time difference. Okay. Okay, thank you.